Hello friends, welcome back my YouTube channel MS Maths. In this video, I will discuss basics of group theory. So in the series of basics of group theory, this is my part 2 in which I will discuss complete topics related to this. Congruent modulo, linear congruent modulo, properties, results and some question related to this particular properties. This is helpful for IIT-JEM, CUET, PG, NBHM, TIFR, CSIR-NET and GATE mathematics. My name is Manoj Solanki and I will start the video. Please like the video, share and subscribe the channel. Okay. So first of all, what is the concept of congruent modulo that we will discuss and what is the definition here? Before going to that, we should have an idea about that what is modulo. Okay. So whenever you will have any kind of example like this, for example 6 equivalent to 2 mod 4. So this is what? 2 mod 4. Okay, so this is something related to modulus, and modulus means I will take the example. Let's say if I will take z integer. Okay, this is a set in which elements starting from 0, 1, 2, 3, 4 and 5. Why this much element only here? Why? What about 6? What about 7, 8, 9, 10? So modulo means this is nothing but z mod 6. Okay, whatever I will take the value of integer. For example, if I will take 36, what do you mean by 36 mod 6? It means you will just divide this 36 with 6 and you will find the remainder, and of course you will get 0 in this case. So this 0 is already here. This is the part. Okay, it means 36 is also the part of this. Okay, what about 7 mod 6? Now 7 mod 6 means that 7 divided by 6, what is the remainder? So if we will divide one time, we will get remainder as 1. It means this will take 1 and 1 is also here. It means this is particular set which is containing all the elements or all the integer with modulo 6. This is the meaning of modulo here. Okay, that we are going to discuss. So here we will discuss congruent modulo first, and then we'll go for Chinese remainder theorem and all the linear congruent theorem also. So let n be a fixed positive integer. A and B are two integer are congruent modulo n if n divides B minus A. If my n is dividing B minus of A. Okay, it means if A is equivalent to B mod of n, if it will be a congruent modulo if and only if my n divides A minus B. Okay, here what is A? That is 6. So A 6 minus 2, that is A minus B divided by n. It means n means 4. So what is this? 4 by 4, that is 1. Yes, it is dividing. It means it is a congruent modulo here. For example, this is what? 6 minus 3 divided by 4. This is what? 6 minus 3, 3, 4. So it means 4 does not divide 3. So is it a congruent modulo? No, it is not congruent modulo for this case. So this is the basic definition of congruent modulo that we will discuss in next. Okay, now here n is greater than 0. So n is greater than 1. So we have taken here n is greater than 1. If it is 1, then it will divide to all. Here we can take n greater than of 1. This is the simple definition of congruent modulo. Now there are some note points or results point that we will also discuss here. So first note point is that if A is equivalent to B mod of n and B is equivalent to C mod of n, we have two congruent modulo. First one is this: A is equivalent to B mod of n, and another one is B is equivalent to C mod of n. Okay, then my A will be equivalent to C mod of n. Because of that, second congruent modulo is nothing but the congruent modulo of this B. Then here the result is saying that it will be A congruent C mod of n. Okay, next, if A congruent A equivalent to B mod of n, okay, this is my congruent modulo showing here. Okay, and C is nothing but D mod of n. If I will add both of them, if I will add left hand side, that is A plus C, and it means it will be B plus D, not mod n plus mod n. Okay, mod n plus mod n will be mod n only. Next, we have one important result, and this is a contradictory result, contradictory example. That's what I have written here. If my A equivalent to B mod n, C equivalent to D mod n, then if I will multiply this A into C, B into D, this will be equal. Is it true for conversely? It means if such property or if such form is congruent, now this will happen or not. So it means converse not true. Let's say one example. See, this is what 6 into 2, or yeah, 6 into 2 is equals to 1 into 2, or whatever I can take, 6 into 3 into 2, 3 into 4, and 1 into 2, mod 10. Now just simply, this is my A, this is my C, this is B, and this is D. Now is it really like this, that A equivalent means 3 equivalent to 1 mod of 10? Is it really like this? Okay, we'll check it. And 4 equivalent to 2 mod of 10. It may be like this, 3 equivalent to 2 mod of 10 and 4 equivalent to 1 mod of 10. This is one of the possibility I have written here. Now just check it. We have already checked here that is it a congruent modulo or not. This is the simplest case, that n should divide b minus of a. Okay, now here, what is this? 3 minus 1 divided by 10 is 10 divided by, just see, is my 10 dividing 3 minus of 1? It is not dividing, it is wrong. But here it is a congruent modulo. Here it is a congruent. 12 minus 2 divided by 10, it is dividing. It is a congruent modulo, and this is the form of this A into C, B into D, but this property is not holding. So this is that converse is not true for this particular result. Yes. Next we have A equivalent to B. Then if I will multiply both the side any constant C, then it is also congruent. If I whatever we have, that is 12 equivalent to 2 mod of 10. Is it holding if I will multiply with 4? Now is it a congruent modulo? Yes, of course it is a congruent modulo, because I have multiplied both the side 4, that is nothing but C. Next we have, if A congruent to A equivalent to B, this is a congruent modulo. Then this is that if I will take the power k and b power k, then it is again where my k is 1 and 1 2 3. But again converse is not sorry, converse is not true for this case. How the converse is not true? We have one contradictory example. Just see, what is this? The contradictory example. Wait, the contradictory example is 9 power. 9 is equals to 4 mod of 5. What is this? 3 power 2, and what is 2 power 2 mod of 2. Okay, my k is equals to 2 here. Is it really like this, that 2 congruent mod of this? Because of that 5 is not dividing 3 minus 2. It is not congruent modulo, but its power is congruent modulo. So from here to here it is not true. But if it is not true, because of that it is not congruent, then how can I take the power for this? So this is the case. From here to here it is true, but here to here it is not true. The converse is not true here. Now next, if we have something like this, A into C, B into C, mod of n, then A of B and mod n divided by D, where D is nothing but the GCD of C and n. Whatever the example here, see, it is what? 24 into 6. I can write it as 6 into 4 is equals to 4 mod of 10, or 1 into 4. Yeah, 1 into 4. Then now what is C? C is equals to 4, and what is the GCD of 4 and 10? Just say GCD is 2. Okay, GCD will be 2 here for this case. Then I can write like this: 6 is equals to 1 mod of 10 divided by 2. it means this will be equals to 6 equivalent to 1. B is 1 mod of 10 divided by 2, that is my D, it is D. So 6 is equals to 1 mod 5. Is it a congruent modulo? You can check. 6 minus 1 is 5, and of course this 5 is dividing this 6 minus 1. So this is what we can check the congruent modulo. Next we have linear congruent modulo. Now here we have to find the value of x. Whatever the form ax is equals to b mod of n, it is the linear congruent modulo to n. Okay, now here ax is equals to b mod n has a solution if and only if this d means GCD, this d should divide the b, then after it has a solution, otherwise it has no solution. Just check, just see, it is what, 4x is equals to 2 mod of 8. What is my a here? A is 4. What is my b here? That is 2, and what is n here? That is 8. Now what is the GCD here? GCD of what? GCD of a and b, that is 4 and 2, that is 2. Now just see, sorry, wait, GCD of not a and b, GCD of n, sorry, GCD of b and n, yeah, GCD of b and n, that is 4 and 8, and that is 4. Now here 4 is not dividing this b, 4 is not dividing, it means this d does not dividing this b, so that it does not have any solution. So now how can we find the solution? Before going to that, we should have at least idea of that how many possible x, how many like cases of x should be there, so that we can easily find how many solutions for a particular case of this congruent modulo. For example, this is what ax congruent to b mod of n. Whatever the form of this, you should first convert it into the 1 into, okay, if you will convert into the 1, then after it will be easy to find it. Now how can we proceed forward with this? So if it is x is equals to x equivalent to 1 mod of n, then what is the value of x, or all possible value of x? How can we find that? So that is very easy, we can easily find this using the property of congruent modulo. Okay, now whatever the case given here, you should write just like this. What is the congruent modulo? That is 1. So just try to write like this: x minus 1 divided by 3. What is this? X minus 1 divided by 3. So from here, if you are writing like, okay, if you are congruent modulo already in the form of x is equals to, the coefficient is only 1, okay, so it is 1 mod of 3, then just take this here, 1 plus 3 into k, 1 plus 3 into k, and the possible values for this will be k is equals to, k should be less than of 0, k should be less than of 3. So here k is equals to 0, 1 and 2. So the result for this is, if k is equals to 0, then x is equals to 1. If k is equals to 1, then x is equals to 4. If k is equals to 2, then 6 plus 1, that is 7. These are the result for this congruent modulo. Now next we have 5x is equals to 2 mod of 4. Then what is the value of x, and all possible value we'll find. Just simply, if you have like this, 5x is equivalent to 2 mod of 4, then just write like this, 5 of x minus 2 divided by 4. Now just think over it, which value of x will satisfy this case. So for example, if I will take x is equals to 0, it will not work. Okay, x is equals to 1, 5 minus 2, that is 3, 3 divided by 4 will not work. Okay, x is equals to 2, then it will be 10 minus of 2, that is 8 divided, yeah, it will work. So it means this is the x value. Again 3 will not work, and x is 4 will work. 20 minus 4, sorry, 20 minus 2, 18, it will not work. 6 or 3, 15 minus 2, that is 15 minus 2 is 13, that will also not work. So x is equals to 2 will only satisfy with this. So here the x value you can write like this simply, 2 plus 4 of k, and where k is your 2. This is simple. You can find the solution. We'll see in the detail. Okay, next we have one question here. 4 of x is equals to 8 modulus of 12, and the next one is this. Okay, we'll see these both example. How can we solve these examples? So first of all, if you have this 4x is equals to 8 mod of this, if you are able to divide in this, so can I write like this? If I will divide, then it will be 2, then it will be mod of, if I will divide here, then 12 by 4 is nothing but 3. Now, is it a congruent modulo? Yes, it is a like linear congruent modulo. Now I can I find the solution for this? It is simple. You will just write like this: 2 plus 3k. Now put k is equals to 0, k is equals to 1, k is equals to 2, and k is equals to 3, because it is up to 3. So if it is k is equals to 0, then x is equals to 2, k is equals to 1, then x is equals to 5. If k is equals to 2, then 6 plus 2, that is 8. Okay, and if k is equals to 3, then it is 9 plus 2, 11. So these are the simple answer. But now in this case, it is what? 6x is equals to 8 mod 14. Now I can't divide. If I will divide, I can divide like this only. It is 3 of x is equals to, it will be 4 mod of 7. Now from here, it is not. From here, if it is 1, then I can write simply in this case, but it is not 1. So I have to just write like this: x is equals to 4 into 3 inverse and mod of 7. Now how can I find the inverse? What do you mean by inverse here? So I will find the inverse here. That is very simple. How can I find? So let's say it is 3y is equals to 1 mod of. Inverse means here it will be 1 mod of 7. Okay, so if it is mod of 7, then I will just write like this. I will find the GCD. So what is the GCD of 3 and 7? That is 1. Okay, if it is like this, then there is a case D is equals to N. N means this. Okay, N plus 3 into Y. So it is 1, that is 7, plus 3 means this is A. So 3 and something here, which will satisfy this case. It will be minus of 2. If it is minus of 2, then 7 minus 6 will be 1. Okay, then here for what? Minus of 2 mod of 7. So minus 2 mod of 7, is it really like this? If I will find mod of 7, can I write like this 5 mod 7? Yes, because of that it is what? Minus of 2. It is not, if it is minus or negative value, 7 minus 2 is what? 5. So this is what? 5, and this is nothing but 3 inverse. I will just replace this to here. So my x is equals to 4 into 5 mod of 7. If it is mod 7, now it is x is equals to 20 mod of 7. Now if it is 20 mod 7, I can easily replace this with what? 7 2s are 14, and 20 minus 14, that is 6. So it is nothing but 6 mod of 7. So what are the value of this? Simply write like this: 6 plus 7 into k, and again k is equals to 0, k is equals to 1. You can find the solution. This is the trick. The main concept is that make the coefficient 1, write like this, and this is the procedure how you can find the inverse of this particular number. Next, we have Chinese remainder theorem. This is one of the important question here and one of the important concept. This is what? If you have these types of system of linear congruent system, then you can find one common solution. There will exist one common solution if all the GCDs, all Mi, Mj is GCD is 1 for all I not equals to j. Okay, now what? These are the M1, M2, M3. If GCD for all the pairs, if it is equals to 1, then we can say it has a solution, common solution. Okay, now method to solve. First of all, you have to find M. M is nothing but M1 into M2 into M3, and then find B1, B2, B3. Now it is what? B1 is M upon M1. That is the multiplication, whole multiplication divided by M. M divided by M2, M divided by M3, M divided by M4 if you have 4, 5 and so on. Then after construct new congruent, this is what your new congruent, and then solve this. How will you solve this? You will have the solution, that is what b1 a1, that is what b1 a1, or you can say bi ai into xi, individual solution, bi ai into xi, and then summation. Okay, if you are calculating the solution, so your x will be summation of bi ai and xi. This is your solution for this common problem. So this is the Chinese remainder theorem. Okay, we'll see one problem so that we can easily get the concept. Okay, here are some calculation I have already calculated, then after I will show you. Yes, so we have this question. So here, first of all, what is my a1? A1 is 1. What is my a2? That is 4. These are the a1 and a2. And what is my m1? That is 7. What is my m2? That is 15. So from here, my first step is to calculate m. That is nothing but m1 into m2. That is 7 into 15. Okay, and after that, I will just calculate b1, b2. That is nothing but m upon m1, m upon m2. So I have calculated the value. That is simple. Yeah, this is 105, and this will be 105 divided by, if I will divide by 5, then this will be 15, and this will be 7. So I have b1, b2, a1, a2, and all these things. So can I construct my new congruent? That is nothing but b1 a1. Okay, what is that? New congruent will be like this. Let's say my new congruents like this: b1, okay, b1 x1 into 1 mod. Okay, because of this, because of that, this will be my new form. Okay, b1 x1 1 mod m1. So b1 x1 1 mod m1, and another one is b2 x2 1 mod m2. Now here, what is my b1? b1 is 15, so it is 15 x1 1 mod of m1. Okay, then again it is 7 x2 1. Okay, what is my m1 here? m1 is also 7. m1 is 7, so mod 7. So from here, this is mod 15. Okay, now my target is to find the common solution. So the common solution will be x is equals to b1 x1 a1 plus b2 x2 a2. Okay, now I have b1 a1, but I don't have x1 x2. Can I calculate? Yes, I can calculate. From here, if I will find, it is nothing but 15 x1 minus 1 divided by 7. Or from here, it is nothing but 7 x2 minus 1 divided by 15. So that's the simple case we have done the previous question. From here, I can just simplify like this. This equation, this particular equation, I can simplify. How can I simplify? If I will take mod, if I will take mod from here, okay, wait, this 15 of x, okay, if I will take this 15 of x, and whatever I will take mod here, so 15 is nothing but, if I will take mod of this, then this will be 1 x1 and 1 mod of 7, because of that 14 minus 15 minus 14, that is 1 na? So 15, oh sorry, 14 minus 1, that is 15 divided by 7. So it has a solution, that is simple identity solution. X1 is equals to 1, so no need to bother of this. Just if you can like find the mod of this a and n. Okay, next, the problem in this case, what is the GCD here? Just take the GCD of 15 and 7, that is 1, because 7 is prime number. Yeah, GCD is 1. Now how can we find the integer? Just see. Now our target is to find x2 here. GCD is 1. We will just write n plus, okay, n plus a into y. It means my target is that I will just write x2 is equals to 7 inverse then mod of 15 here. This is my target, and now I have to find what? 7 inverse. So can I find 7 inverse from here? Yes, I can easily find 7 inverse from here. That there are two methods I will explain. So first one is this. So x2 is equals to 7 inverse. Okay, that we have already used here, I think, in this question. This is the problem. This is the way that we are going to use it. Let's say it is my y. Okay, now what is the GCD? That is 1. Okay, what is the modulo? That is 15 plus 7. What will I write? That it will be 1 only. So can I write minus of 2 here? Can I write minus of 2 here? Yes, of course I can write. Then it will be equal. So it is nothing but minus 2 mod of 15. Now just see here what I have done. If it is minus 2 mod of 7, then 7 minus 5, that is 7 minus of 2, that is 5. And here it is minus 2 mod of 15. Then it is nothing but 13 mod of 15. This is one of the way that you can find. Another way how you can find, from here just see that 7x2 minus 1 divided by 15, which value will satisfy this. You have to put the value and you have to find. Now from here, this is the 7 inverse, this is the 13. So from here, if I will write like this, x of 2 is nothing but 7 inverse mod of 15. Because of that, here it is 1. So my x2 is nothing but 13 mod of 15. So this is my x2 here. So I have x1, x2, b1, b2. I can easily find x0, that is the common solution, b1, x1, b1, x1 and a1 plus b2, x2 and a2. I can easily find the solution. That is what I have calculated here, the calculation part. That is what b1 is 15, b1 is 15, x1 is 1, a1 is what, 1, plus it is what, b2 is 7, x2 is 13, a2 is 4. So it is nothing but 15 plus 364, that is nothing but 379. And if I'm going to write this, 379 mod of 105. Okay, this is the solution. 105 means mod of m. This is what my m. So my solution form is nothing but x0 is equals to summation bi xi ai mod of m, and m is nothing but m1 into m2. This is what the concept using the Chinese remainder theorem. This is all about the Chinese remainder theorem and the topic. I hope you are understanding the concept, and this is the basic part 2. For the further more videos, you can follow my YouTube channel. Just subscribe the channel, like the video, share the video. Thanks for watching my video. Keep watching MS Maths. Thank you. Bye bye.